On we go to our next example. In this example, we're going to use a velocity time graph, okay, shown here, to draw a corresponding acceleration time graph. Okay, so to get started on this, we're going to take a quick look at the graph, and we see that between 0 and 8 seconds, this graph has a constant slope. Okay, and then between 8 and 12 seconds, it's got a slope of what looks to be 0. And then a slope here between 12 and 16 seconds, it's got a slope which is quite steep. We know that acceleration is equal to the change in velocity over time, which is basically, in terms of this graph, we're basically looking for slope values. So we'll say that the graph between 0 and 8 seconds, it's going to have an acceleration which stays constant, and we'll basically go, so we'll take these 2 points to calculate our slope. So it's going to be, this corresponds to, let's say it's 2.5 there, so 2.5 meters per second minus 0 over 8 seconds minus 0. This gives us a value of 0.3125 meters per second squared. Okay, in the next stage, the acceleration is found by this slope, the slope of this part of the line right here. Okay, so we're going to have 2.5 meters per second at this point here. Subtract away 2.5 meters per second, and then the time that goes by here is 12 seconds minus 8 seconds. Of course, this works out to be 0, right? So 0 slope in this section here between 8 and 12 seconds. Finally, between 12 and 16 seconds, we'll calculate acceleration. We're going to need 2 points, so we'll take this one here, and I'll say that that's 1610. So the slope here is going to be 10 minus 2.5 divided by 16 seconds minus 12 seconds. This is in meters per second in the numerator there. Okay, so that works out to be 7.5 meters per second is the change in speed. Change in time is 4 seconds. So 7.5 divided by 4 is 1.875 meters per second squared. Okay, so I've just put together three ordered pairs, or 3 different accelerations for 3 different stages through this graph. So during this stage of the graph, the acceleration was, we calculated it to be 0.3125 meters per second squared. Okay, our acceleration. And then in this stage, our acceleration is 0. And in this stage, our acceleration is 1.875. So we can use that information now to plot an acceleration time graph. So here it is. I've set up my Cartesian plane, and I'm going to prepare my acceleration time graph now using the information I've taken from my velocity time graph. Okay, so for the first 8 seconds, the acceleration is 0.3125. So it's going to be a line somewhere around here, what was that again? That was from 0 till 8 seconds. Okay, so that's going to go all the way across at a constant acceleration until we get to 8 seconds. And then at between 8 and 12 seconds, the acceleration is going to be 0. So it's going to follow along right until 12 seconds. And then at 12 seconds, we move to a new acceleration, 1.875, almost 1.9. So this moves up to somewhere in that neighborhood and then traces across till we get to the end. Okay, so this is how we've created a new graph. From a velocity time graph, we can create an acceleration time graph using the information that's provided to us from that graph and calculating some slopes, etc.